Hello and welcome to Algebra 2 tutorial. In this video we are going to take a look at exponent properties and root properties. Now that we're taking a look at root and exponent functions, there's a few properties that we have to know to manipulate these mathematical expressions. So we're going to take a look at those properties. One important offshoot of that are the negative exponents. And then we just got to sort of practice these to make sure we can manipulate these expressions quickly, and then we kind of understand how all that works. So let's dive right in and take a look at those exponent properties. I'm hoping a lot of these look familiar. Most of them are left over from Algebra 1, but we might need a quick refresher. So the first is if you have two bases that are the same and you're multiplying, you can add the exponents. So you have 4x's over here and 5 over here. You have a total of x to the 9th. All right, that's a real simple one, but you do have to remember to add those exponents. As opposed to here, if that fifth power is on the outside of parentheses, now you multiply those exponents. And technically there is a 1 right there, so this one multiplies. So 5 times 2, that means we have x to the 5th times y, what am I saying, x to the 5th? X to the 10th, y to the 5th. There we go. And here we can't do anything here because the bases are not the same, and so we can't add the exponents here. So that stays separate. So this one is also similar, but we have a fraction on the inside. Again, that 7 distributes to both of them. And so on the top we have an x to the 7th and a y to the 7th. Now what happens if we have a fraction but the bases are the same? So now we have x on top and x on the bottom, whereas over here it was x and y. Well, if it's x on top and x on bottom, you can simplify that by crossing out or eliminating some of those variables. Imagine there's 6 x's on top and 5 x's on the bottom. We can just start crossing off the pairs, and here we'll be left with an x on top and no x's on the bottom, so it's just a 1. And so we just have 1x left over. You're essentially subtracting those exponents. I'm hoping those are pretty familiar. Now some of the root properties you may be slightly less familiar with. This one we just looked at in the last video. So remember, a fifth root is a 1/5 power. And so this is x to the 4th on the inside still. And then if you want to, you can use this exponent property right here and distribute that 1/5 in, so we get x to the 4/5. Alright, a few other root properties. If you have two numbers or variables inside a square root, you can break up that square root into two square roots that are multiplying. And if they are dividing, you can break that up into two roots. In this case we got a cube root, and make those cube roots divide, x and y. So you can split it up into two, and of course you could go vice versa. If you have two roots, you can turn them into one big root. And if you have two roots that are multiplying, you could go backwards and turn them into one square root. Alright, so those are just a few properties there that we can do with exponents and roots. Want to refresh your memory there. Oops, not sure why that happened. Alright, so now negative exponents. So we've done some of those root and exponent properties. They have an important implication for negative exponents. So we actually don't know what happens here. What happens if your exponent is negative? Like right here, we have 2 to the -3 power. We haven't done that. We've only done positive exponents up here. So we've got to figure out what those do. To do that, we got to start with what we know. Let's go down to here. We know what 2 to the 1st power is. That's 2. And we know what 2 squared is. That's 4. 2 cubed is 8. And this pattern gets pretty easy. 2 to the 4th, we would multiply by 2 and get 16. So the pattern this way is pretty easy. Every time we're multiplying by 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. The next one would be 32, the next one would be 64, etc., etc. Now, what if we go backwards? So, let's follow the pattern. If I'm going backwards, we are dividing by 2. So 16 divided by 2 gives me 8, divide by 2, divide by 2. So if I want to go to 2 to the 0 power, if we forgot what that is, we would simply divide by 2. Well, 2 divided by 2 is 1. And if we want to get to the negative 1 power, we continue that pattern and we simply divide by 2. So there's the 1 divided by 2. So 2 to the negative 1 power is 1/2. Well, if we want to do that again, we're going to divide by 2 again. So 1/2 divided by 2 is 1/4. Half of a half is a fourth. And if we divide that in 2 again, hopefully you can see we're just going to multiply the denominator by 2, so that will be 1/8. We cut a fourth in half, divide it by 2, you get down to 1/8. So we have a pretty good pattern here. If we kept going, hopefully you can see the next one would be 1/16, etc., etc. And so to rewrite that, we want to think of this one. The 1/2 is good, but think of that as 1/2 to the first power. Because we know what 2 to the first power, it's 2, and then it's just in the denominator. This one here is 1/, where did the 4 come from? 2 squared. And where did the 8 come from in this one? 1/2 to the third power. And so we just take the regular exponent, 2 to the third power, we know that's 8, and the negative moves it to the denominator. All right, now that works really well for 2's. Let's double check this for 5's. So 5 to the 1 is 5, 5 squared is 25, 5 cubed is 125, and if we multiply by 5 again, that would be 625. But now we're going to continue that pattern backwards. So to go from 125 back to 25, we divided by 5, divided by 5, and so here we're going to divide by 5. 5/5 is just 1. And that's kind of interesting that anything to the 0 power is 1. It doesn't matter if it's 5 to the 0 power or 2 to the 0 power, that is always going to be 1. They all have that in common. But let's keep going with our pattern. To divide that by 5 again, it's 1/5. Divide that by 5 again, that makes the denominator get bigger, 25. And divide that by 5 again, 1/125. So again, you're seeing that this negative exponent is sending the number to the denominator. 5 squared is 25, but that negative moves it to the denominator. So that works for any number. Let's just pick a random example here. Let's do 10 to the power of -3. What would that be? Well, first we think, what is 10 to the third? That is 1,000. But because it's negative, it has to be in the denominator. So 10 to the -3 is 1/1000. All right, so that is negative exponents. That's a really important thing that we use over and over in mathematics. So now we've just got to get comfortable with using these properties and manipulating them to whatever we want to do. So here are some examples that we're going to do together real quick to see how this works. So on this one, I see I've got 2 square roots, one on top, one on bottom, and they're both a 5th power. So I could write that one as 1 big 5th root of 128/5 if I wanted to. Okay, that may or may not be helpful, but you can do it. These two are the same. All right, here I've got 2 square roots that are multiplying. That means I can write it as 1 square root, 3 times 75. Well, if I wanted to, I could then multiply those. 3 times 75 is 5, 1, 21, 22. We've got the square root of 225. All right, which I believe is at 15. Looks about right. Now, over here, we've got something much more complicated. 7 to the negative 3/4 times 7 to the 1/4, all to the negative 1 power. Let's see, let's just tackle this one piece at a time. First thing I see is I can take this negative 1 and distribute it. So 7, negative 1 times negative 3/4 is just 3/4 times 7 to the negative 1/4 power. And then let's see, what can I do with these? Because I have the same base, we can now take the exponents and add them. So that will be 7. 3/4 and negative 1/4 is 2/4, which is just 7 to the 1/2 if you want to reduce it. And then 1/2 power, if you like 1/2 power, that's all good. But 1/2 power is just a square root. So you could also just rewrite that as the square root of 7. They are the same. Whichever one you like better, you can use. All right, one more here. We've got different bases, same powers though, and then all to the power of negative 1/5. So if I remember the exponent property, we can distribute. So that will be 6 to the power of, let's see, 5 and negative 1/5 is negative 1 over 9 to the power of, and again 5 times negative 1/5 is negative 1. Now here's an interesting problem here. So 6 to the negative 1. 6 to the 1 is 6, but a negative exponent moves it to the denominator. So that 6 is actually going to be in the bottom. Now the 9, interestingly enough, this one is also going to switch. Think of it like a reciprocal almost. The negative 1 exponent is going to take this, because it's already in the bottom, it is going to go to the top. So we actually have 9 over 6, and if you wanted to reduce that, you could divide them both by 3, and you get 3 over 2. So you can definitely see sometimes doing a manipulation, you can really make these much, much simpler. All right, so there's a few good examples of how to manipulate expressions using these properties. The better you are at them, the easier your life becomes in mathematics, because oftentimes they are a middle step to doing what you want to do. So let me give you a few practice problems to try out yourself. Work on manipulating these using the exponent properties, using negative exponents, and rewrite them. Sometimes you'll get a more simple statement, sometimes you won't, but just try to rewrite them. Good luck.